All right, here is some video help for parts B and C of this problem from 10.1.5, the homework problem. And what we have is a diagram where you have a circle O and this tangent line to it. And what we learned in 10.1.4 was that if you have a radius of a circle and it goes out to that point that intersects that tangent line, that creates a 90-degree triangle. So we actually have a right triangle here. And we actually know two of the values of that right triangle. OE is 20 and OXE is 15. And so we're actually going to use the fact that this is a right triangle to help us solve a couple things here. One, we need to figure out what that central angle is. And so that's the first part I'm going to do here, is trying to find that central angle. And what I'm going to do is, since that's my angle O, and opposite of it is 15, and really 20, because this would be my right angle right here. 20 would be across from the right angle, which means that that's my hypotenuse. So I have opposite hypotenuse. This becomes a sine problem, and because we're looking for an angle, it becomes a sine inverse problem. And so we do the sine inverse of the opposite, which is 15, over the hypotenuse, which is 20. And if we do that, we'll have our central angle for that sector. Because really we're looking for this sector right here. Kind of poorly drawn, but it's that little slice of the pizza that we're looking for. I just got to bring my calculator out to do this. The sine inverse of 15 divided by 20 gives me an angle that is equal to 48.6 degrees. All right. And then the next thing I need to do is I need to figure out what this radius is, OX, because I need to figure out the radius so that I can figure out the area of the whole thing. And then when I have the area of the whole thing, I can multiply it by this portion, 48.6 over 360, because that's the area of the portion I want. So I need to find next the radius, which I'm going to use Pythagorean Theorem for. So I'm going to do a squared plus 15 squared equals 20 squared, because 20 has to be on this side because 20 is my hypotenuse. So when I start working this out, I get a squared plus, I got to do 15 squared on my calculator, is 225, and 20 squared I believe is 400. I subtract this over and I do 400 minus 225 and I get 175. And if I square root both sides, I get that, sorry, I gotta find my square root function. The square root of 175 is 13.2. So that length for A is 13.2, which is my radius. And I'm actually gonna move, because I'm running out of room, I'm gonna move down to part C, and then I'll move part C down as well for the next part. And so we have 13.2 is my radius and a central angle 48.6. So let's find the area of that circle. The area of a circle is always pi times the radius squared. So the area of this circle is equal to pi times 13.2 squared, which gives you an area of 174.24 pi. Now I'm going to take my area here, 174.24 pi, and I am going to multiply that by the portion that I want, which is 48.6. So 48.6 over the 360, because we're talking about the portion of the entire circle. And then I just need to plug this into my calculator. I do 174.24 pi, and I multiply that by 48.6 divided by 360, and I get that the area of that region, so area of that region, I'll call it AR for area of region, is 73.8. Actually, we'll round that up and do 73.9. I'm going to do part C so I can clear my work. I'm going to do part C in a second video.